Everyone. My name is Ajiboye Isaac, and today we also want to look at another example, the uses of analysis of variance model, in particular to multiple linear regression. The example we have here, the income Y of an artist depends on the educational qualification X1 and years of experience X2. We want to test at 5% level of significance whether the change in income level can be explained by the changes in educational qualification and years of experience. And this is the data we have from our observation. Um, we have x1, x2 columns and y column. As usual, the structure of our ANOVA table is presented in that table. So basically the sources are regression, error, and total. And then the sum of squares are also as expressed. As you can see in the column there, we have representation of matrix form to be able to get the sum of squares. So it's very important we are familiar with multiple linear regression representation in matrix form, and that is the model that is represented as Y, matrix Y, equals to the product of matrix X by the product of the parameter matrix plus the error matrix. It's important to state our null hypothesis, stating that beta 1 is equal to beta 2 and they are equivalent to 0. And our alternative hypothesis H1 is beta 1 is not equal to beta 2 and they are not equal to 0. So what we then do is to expand the table so that we can get the totals from the different columns that we have there. So this will help us to obtain our x prime x matrix. The formula is also represented in the matrix to obtain the entries. And then after obtaining the x prime x matrix, find the inverse of that matrix. And when we do that, that will give us the matrix that we have there, a 3 by 3 matrix. Then the next thing will be to obtain our x prime y matrix. The formula to obtain that as well is also stated. Then we can get those values from the table. And so the next thing to do now is to obtain our sum of square total, which is y prime y, and we can calculate our y prime y as the square of all the y entries. Then we can also calculate our sum of square regression, which is beta prime x prime y. And then by the time we do that, that gives us 408.69 minus 351.125. So our sum of square regression is 27.561. Sum of square total is 69.875. And then it's a common practice to subtract the sum of square regression from the sum of square total to obtain the sum of square error. And so once we obtain the sum of squares, we input into our table with the corresponding degrees of freedom. We can then determine our mean squares. From there, we can determine our F ratios. So now that we obtain our F ratio, we therefore go to the table of statistics, F distribution table, to obtain the F tab value at corresponding to F at 0.05 significance, level in alpha, and 2,5 degrees of freedom. That value is 5.79. So the next thing is to draw a conclusion. Since our best stats, which is equivalent to 11.685, is greater than the F tab, which is equal to 5.79, we reject the null hypothesis that there is no regression, therefore conclude that there is evidence that the predictors jointly explains variation in Y. To know how much of the variation in Y is explained by these predictors, we therefore need to determine our coefficient of determination. So our coefficient of determination, R squared, is the ratio of the sum of square regression to that of the sum of square total, and then times 100 in order to get a percentage. So that gives us 57.561 divided by 69.875 times 100, which is equivalent to 82.38%. Invariably, we are saying that 82% of the variation in income is explained by educational qualification and years of experience. And so this is how we apply ANOVA model to analyze multiple linear regression. I hope this video has been helpful. If it is, use a thumb up, comment in the comment section, like and subscribe. Also share with your contacts that this video may help. Thank you.